This is Novelytics, developed by Jacobson, Wilber, Huang, and William Han. So Novelytics is designed to make novelty searches more accessible for small-scale inventors in specialized fields like quantum photonic circuits. Now, why do we do this? Patents in the US have increased immensely in the past 30 years, especially in electronics and computer and communications. We heard the story of physicist Gordon Gould, who conceived the laser, yet spent nearly 30 years fighting to obtain his patents, largely because existing documentation of prior art searches failed to recognize the novelty of his idea. Thousands of inventors struggle to patent their ideas. Our app aims to solve this issue by providing prior art searches. Now the app functionality is extremely simple. So first, the user inputs their patent. Then, the system embeds the user's patent. And third, the system compares the user's patent with over 30,000 patents in our database. Fourth, it returns the top matches. And fifth, the user reviews the results.
Hi, my name is Wilber Huang, and let's get into our data collection process. So first, on Google BigQuery's official datasets, there are US patents that are open to the public. And by using that, we use those to target specifically quantum photonics. We use keywords that always pop up in quantum photonics and use the English language so we're able to compare our user input with the vectors that we have. So then, using standard query language with those two key things in mind, we were able to get 30,000 key quantum photonic patents in English. Now, for our front end, we used JavaScript with the libraries of React, Axios, and Materials UI. These were used to create an interactive web UI with buttons that users can interact with and input their own claim and description that we then use for our backend. For our backend, we used Python and Fast API. Fast API was used to connect both our website with our backend, which we then can use for our vectors. And then Python was used for every type of process that we use. To compare vectors, to compare our claim versus claim, Python was the main thing we used for all the complex aspects of our code.
Here, the user can enter the title, claim section, description of their invention, as I've already done. After pressing search, the app returns the top matching patents, each showing its title, publication number, and similarity score. In the settings panel, users can switch between cosine and Euclidean distance as their metric. They can also adjust the relative weighting between claims and descriptions. For example, if the goal is to find patents that are technically similar, the user can emphasize descriptions, but if they're looking for patents that are legally similar, the user can emphasize claims instead. Finally, users can choose how many results they like to display.
From creating Novelytics, we learned how to connect machine learning models with our website and backend, balancing efficiency for small-scale inventors and being able to interpret them and give them the most similar resulting patents with them. So for society as a whole, it leads to faster innovation, leading to more inventions being created without the long wait times that we had in 1900s with a 30-year wait time. And now, if we were to create a new version, what we would do is include more patents with a more variety, with more quantum devices. And additionally, we would implement a novelty density metric. This gives them the most competitive fields and where they want to focus on their invention. So thank you for listening, and I hope you learned something.